Hello, we are looking at transformers and power for this video, and we are going to look at how the power relates to the primary side of the transformer and the secondary side as well. But before we begin, here's a quick recap in terms of what the transformer is all about. We've done a video on this already, so you've got more details in a previous video, but just as a quick recap, here's our transformer. We've got an iron core, and the reason why we have an iron core is because it's magnetic material, and that helps the transformer to work better. We have a primary coil on this side, and the primary coil is connected to our alternating current. On the other side we have our secondary coil, and that is the output, and here we generate a potential difference, so we induce a potential difference on the output side, and if that is connected in a circuit to a device, that can then cause a current to flow. And we can do some calculations based on the number of coils and the potential difference on each side, and we can do some working out based on that. We've done that before, but what we're going to look at today is the idea of the power that's on the two sides of the transformer. Now, one thing to remember is that if this transformer is 100% efficient, and we do work on the basis that it's 100% efficient, the power over this side will be the same as the power on the other side. So if we have, say, 10 watts of power over here, on the other side we also have 10 watts of power. Again, that's assuming that we are 100% efficient and we're not losing anything along the way. There is a way we can work out power when we are dealing with electricity, and that is by multiplying the voltage, or the potential difference, times current. So the power over this side is 10 watts, and that will be the voltage times the current, and over here it will be the same. It will also be the voltage times the current. But we can have different values for voltage, or potential difference, and current on either side. So let's just have a quick example. Say we have 10 watts of power over here. That could be made by 5 volts of potential difference versus 2 amps of current, and that will give us our 10 watts. And over this side, we could actually, because this is a step up transformer, we could have an increased voltage of 10 volts, but because the power has to be 10, that means our current must be 1 amp in order for our power to be maintained at 10 watts. So you can see here this step-up transformer has increased the potential difference, but we had to lower the current, or the current was lowered, in order to make sure this power stayed the same. So we have more power, less current, and we can actually put this together into an equation that we can use, and this equation will be given to you in the exam. But again, remember, while they tell you the meaning of these different things, they won't give you the units. So the units, or the meaning of these, are: we have the primary potential difference, which is the VP, which is multiplied by the primary current, secondary potential difference times the secondary current. The units here are volts. This is in amps. Again, volts and amps. And as you know, power is actually in watts. And if we know how much electrical power a device requires to work normally, this will then tell us how much electrical power must be supplied to the transformer. It's probably worth having a go at an example right now. So if you want to have a go at this now, give it a go and see if you come up with the same answer as me. If not, just carry on watching and we'll go through it together. Right, so first thing is to get our equation. So we have a transformer is used to change 230 volts mains electricity supplied to 12 volts needed to operate a household appliance. The current through the household appliance is 4 amps. So we're trying to work out the current drawn by the transformer from the mains electricity. So if we plug in the figures, we have 230 volts from the mains electricity, that's the input, times IP, the primary current, which we don't know because we're trying to work out the current drawn by the transformer. On the other side we have 12 volts, and we know this thing runs on 4 amps. Shouldn't have put the units in there, but I have done, never mind. So we can then simplify this a little bit. 12 times 4 is 48. That gives us 230 times our primary current is 48, and if we rearrange our formula, we have our primary current is 48 over 230, and that gives us an answer of 0.208 amps, which we can round to 0.21, which we can round to 0.21 amps. Okay, so this is the idea of the transformer and power ratings on each side of it. One last thing I want to look at is a new topic that's been introduced to the Unit 3 for physics, and that's this idea of a switch mode transformer. And a switch mode transformer is one that runs off a much higher frequency than your regular transformer, and that gives it a couple of advantages in terms of where and how it can be used. So a couple of pointers for this is that one, it works at higher frequencies, which are 50 kilohertz up to 200 kilohertz. The regular transformers that we talk about usually operate at around 50 hertz. I think I might have written that down here somewhere. That means they can be much lighter and smaller than transformers working from the mains, and these are our regular 50 hertz transformers that we've been talking about. So remember, these work at a much higher frequency, and what actually happens inside here is that because the mains electricity is supplied at 50 hertz, we have to have a little device in here that increases the frequency of the alternating current supplied up to 50 kilohertz or more. So this gives the advantage that they are much lighter and much smaller than transformers working from the mains, and that makes them useful for devices like mobile phone chargers or laptop chargers, and that's because they use very little power when they are on, but nothing is connected. And the way we say that is that there's no load applied, so they use very little power when they are switched on, but nothing or no load is applied. So if you've got your mobile phone charger and it's plugged into the wall, it's going to use very, very little power, and obviously that's useful because it doesn't, one, waste electricity or waste energy, and two, saves on the electricity bills. Okay, so that's what switch mode transformer is all about. Slightly different to our regular transformer, and you should be able to describe these differences and reasonings for how and when we use a switch mode transformer. Okay, but that's the topic of transformers just about covered. Thank you for watching, and I'll see you again soon.